Okay, so let's try and look at some ideal equations that are very vital in the on transformer. So let's look at the transformer. Now, from what we looked at, we said the transformer has got three things. That's where I think I would love to start from. We can look at the three features of a transformer. Three features. One, we say there is a primary coil, whose number of turns on the primary coil are abbreviated by AP. And then two, we have the secondary coil. We have the secondary coil, okay, whose number of turns on the secondary coil are abbreviated by NS, number of turns on the secondary coil. The fifth one is the soft iron core. Soft iron core. Now, because of the nature of the iron, we say that there are times they ask questions, why is it that in the transformer they prefer using the soft iron core and instead of the steel? It is because a soft iron core is easy to magnetize and easy to magnetize. So it is easy to magnetize and then demagnetize. Okay, so yeah, that's where I would love to start. The three important features of the transformer are the primary coil, whose number of turns in the primary coil abbreviated by NP, and the number of turns, and the other feature is the secondary coil, whose number of turns in the secondary coil are abbreviated by NS. Okay, the fifth one is a soft iron core. But why do we use soft iron core instead of steel? It is because iron is easy to magnetize and also very easy to magnetize. So because of this property that iron has, that is the reason as to why the core, the central part of the transformer is made of iron. Now, remember we're saying that the transformer is able to change the voltage. Okay, so if you have the voltage in the size of the voltage in the primary is abbreviated by VP, and the voltage in the secondary is abbreviated as VS, because one of the ideal equations that we have, these are the aspects that are very vital. So the number of turns in the primary abbreviated by MP, and the voltage in the primary is abbreviated by VP. The number of turns in the secondary coil, which is the second feature, is abbreviated by NS, and the voltage in the secondary is also written as VS. So now, today's point of focus is just only the calculations that are performed. Now, like the way I was saying the other day, say when you have your charger, you're trying to charge your phone, if you plug your charger on the power supply for quite a longer period of time, you find that the charger head will get heated up in some ways. Why? It is because part of the current or electricity which is applied on the charger or on the transformer is converted to other forms such as heat. When you're passing around the transformer, these big transformers, you can hear the sound coming from the transformer. So that sound is not what we need the transformer to be producing. Okay, so because heat and sound are those are some of the byproducts that are produced. But all the calculations that are performed under the transformer, we take an assumption that the efficiency of this transformer is 100%. Okay, so the first assumption which is done, on this transformer is that the transformer has 100% efficiency. So if this transformer has the efficiency of 100%, the first equation, which is very vital, is that the power that goes on the primary must be equal to the power that comes out on the secondary. Okay, so the first assumption is that this transformer is 100% efficiency, has the efficiency of 100%. So if the efficiency is 100%, that means the power on the primary must be equal to the power on the secondary. Now, if that is done, okay, if this is the first assumption that is made, but how do you calculate the power? In as much as I know power is given by voltage times the current. That is how we find power. Power is equal to voltage times current. So we are saying that in the primary part, the voltage and so in short we are saying V P I P must be equal to V S and I S. Because we are saying power is equal to power on the primary is equal to power on the secondary, but how do you find power? Power is equal to voltage times current. So we are saying the voltage in the primary in the current multiplied by current in the primary must be equal to the voltage in the secondary multiplied by the current in the secondary. So that is the first important equation that is used when you're told, because they give you the number of volts, they give you the current on the primary, they give you the voltage on the secondary, then they ask you to find the current now on the secondary. How are you supposed to do? So this is the equation that you use. Then the second one is that now the first one talks about voltage and current in the primary and secondary. The second one talks about the number of turns and the voltage. Remember, we said that the stepped up transformer has got more number of turns in the secondary. In the output coil, there are more turns than in the input. So that means the voltage that is coming out, or the voltage that is going in, the size is dependent on the number of turns, either in the primary or in the secondary. Now, how are these two related? So we are saying that the voltage in the primary over the voltage in the secondary must be the same as the number of turns in the primary over the number of turns in the secondary. So this is the second and the final equation, which is very vital. So now, if you want to have it presented in this way, not in a fraction form, you can cross multiply Vp times Ns. You can have Vp Ns, which must be equal to Vs and Np. We're going to have Vs and Np. So these are the two equations that are very vital where the calculations on the transformer are concerned. Now, let's look at the examples. Let's look at the examples. So the first example that we have, remember these equations are very vital, very, very important that you have to remember them every now and then. Now, if you look at some of these examples that we have, right with me, I have them. Let's see how we can play around these equations in trying to solve the question. So the first question, so I'm gonna call this exercise 1. Exercise 1, what we have is saying that a step up, unfortunately, I'm not going to write, I'm just going to read it out. Okay, so it says that, of course, the more information was given. A step-up transformer increases the voltage of AC supply from it increases from one it increases from 110 volts to 220 volts. So this is the voltage that this transformer increases. Now, what can we say from this? It increases from this to that. And remember what I said? I said that the voltage is supplied on the primary coil. So this is a voltage on the primary because that is where the voltage is entering from and coming out of secondary coil. So from here, you can say that the voltage on the primary is equal to 110 volts. And the voltage on the secondary is equal to 220 volts. That's the first information I have. And it does not just end there. It also says that the primary coil dispatches. It also says that the primary coil dispatches the power of 1.1 kilowatts. So this transformer has a primary, which is the primary coil, which is able to dispatch the power. So this is the power on the primary, which is equal to 1.1 kilowatt. But the kilo means 1,000. So kilo means 1,000. That means we need to multiply the 1.1. We're going to multiply by 1,000 watts over 1 kilowatt. It's not always that these conversions must be performed. At times they'll just give you a direct information. So once you divide the kilo and the kilo, you find that the power on the primary is 1100 watts. So this is the power on the primary. Power on the primary is 1100. So that is the information that we are given. And then the question says if the turns in the primary coil is of the turns in the primary coil are 400. So the number of turns in the primary, so the NP, we are told that it's 400. So the 400 is the number of turns according to the question that we have. And then the question goes like, how many turns are there in the secondary? How many turns are there in the secondary? So NS is what we're trying to look at. So the NS is our point of focus. The NS is the point of focus. Now, if you look at the data that we have right over here, this question is very simple because the second equation that I had written earlier on, I said VP over VS is equal to NP over NS. So this is the equation that we're going to use, whereby the number of turns in the primary, the NP, is 400, okay, and then the VS, the voltage on the secondary coil is 220. The voltage in the primary, the VP, so we have the VP, which is 101, 110. So the VP is 110, the VS is 220. When it comes to NP, we have 400. So the NP is 400, and NS is just that question that we are told to find. So what is it that is likely to happen? We're just going to substitute. Okay, we're going to do that. We're just going to do that because this question is very, very simple. Every information that we're going to forget about the power because the power will come when you start looking at the current. Okay, the power thing will be involved when you start looking at the current. For now, the only aspects that I've got here I hope you have this question. The only aspects that are here are the number of turns in the primary, the number of turns in the secondary, the voltage in the primary, and the voltage in secondary. So you're going to allow me to rewrite the question, or sorry, the formula, which is said Vp over Vs is equal to Np over Ns. Or maybe let me just make the Vs, the Ns subject to the formula. I'm going to cross multiply these two. So I will have Vp Ns is equal to Np and Vs. So because I'm told to find the number of turns in the secondary, what I'm going to do is I'm going to divide by Vp here. I'll also divide here by Vp, so that the number of turns in the secondary will be what is the total number of turns in the primary according to the information that we were given. The information that we were given was saying the number of turns in the primary are 400. 400 turns. Multiplied by what is the voltage on the secondary according to the information that I've written is 220 volts. And then we divide by the voltage in the primary is 110 volts. So that the voltage here and the voltage will cancel. The 0 will cancel with a 0 here. And then 11 into 11, 1, 11 into 22, that is 2. So the number of turns in the secondary will be 200 multiplied by 2, and that will give us 800 turns. So the number of turns on the secondary coil will be 800. So that is the information that we have. Now, having found the number of turns in the primary coil, the second question goes like, how much current flows on each coil? How much current flows on each coil? So the question is talking about what is the size of the current in the primary coil and what is the size of the current in the secondary coil. So the second question is going to be, we're going to make use of make use of the first equation that I've written. First equation that I've written is the one that gives the relationship between the voltage and the current, or power in the primary and power in the secondary. So we are saying that the power is equal to voltage times current. The information that I have here is saying that the power that is dispersed in the primary coil is 1,100. That power is in the primary. So let's try to consider the primary coil. Primary coil. Currently, my marker is fainting. So the power in the primary coil, the power we're told that is 1100 watts, which must be equal to, that's the power in the primary. What is the voltage in the primary? The voltage in the primary we are told is 110 volts times what is the current in the primary. Because the question is asking us to find the current on each coil. So we are finding a current here, which we are going to make subject to the formula by dividing by 110 volts, even here 110 volts. So that once these two guys cancel out, then the current in the primary actually will be the 0 and the 0 there, and the 11 and the 11 there. So we're going to have 20 watt per volt. So watt per volt is the same as amps. So the current in the primary coil is 20 amps. So having found the current in the primary coil, it is very easy to link this information to finding the power also in the secondary coil using the same equation that we had driven at first. So what I'm going to do, so this is how it is done. Then if you are to now consider the power in the secondary coil, so secondary coil, we are going to say that power in the primary is equal to power in the secondary. What is power in the primary? Voltage P times current P is equal to voltage S times I S. Okay. Now, what is, according to the information that we have, what is the, remember I mentioned this, I hope you have it. What is the power in, what is the voltage in the primary? The voltage in the primary, we are told that it's 110 volts times, what is the current in the primary? The one that we are from solving, which is 20 amps. Then we say equal to, what is the voltage in the secondary? The voltage in the secondary, we're told that is 220 volts times, now we are finding the current in the secondary coil because we had found the one in the primary coil. So we're going to divide here by 220 volts. Even here, we're going to divide by 220 volts. So once this happens, you find that these guys will cancel out. Then the size of the current in the secondary coil will be equal to, you find that the 0 here and the 0 here will go out. The 20 will divide 22, which is 11. And then when you divide 11 into 110, you find that the size of the current will be 10 amps. Now from this, what conclusion can you draw, or what observation can you make? The primary, the voltage in the primary was 110. The current in the primary is 10 amps. Oh, sorry, current in the primary. That is the information that we've obtained. Then let's try to look at the secondary. So now the voltage in the secondary is 220, and the current in the secondary is 10 amps. So what information can you draw from there? So this type of a transformer, if you are considering the voltage, this is a step-up transformer because it is stepped up or it increased the voltage from 110 to 220. But what was it doing to the current? The current was reducing. So a voltage step-up transformer is the same transformer which is able to reduce the current. Why? Because voltage and current are inversely proportional to each other. When the voltage goes up, the current has to reduce. So that is that's the first equation. If we are to look at the second equation, if we are to look at the second in the last example, let me see how we can extract another question. How we can extract another question. Okay. Where is it? Not this one. Let me try to see how I can make use of this or the other one. Which one should? Not this one, this one. Okay. So I have another one with me, which came, I don't know which way. But now let's see how we can. Again, it's similar again, like the one from play. How we can make use of these two important equations in solving the parameters of the transformer. So let us see how we can make use of these two ideal equations, how we can make use of them. So the second question is saying, Same question, I'll be a little bit faster because the amount of time remaining is just about 10. So the second one saying there's a bit of a diagram. For those that want to be part of this, I can share the question with you. So there's a diagram where the power, the voltage in the, so we have the voltage in the primary is 240 volts, and then the voltage in the secondary, which is a step down transformer, is just 12 volts. The power in the current in the primary, we don't know. Then the power in the secondary is 2 amps. Okay, so the question is saying calculate the number of turns on the secondary coil. If the number of turns in the primary is the number of turns in the primary, where are they? Is 12,000. So the number of turns on the primary is 12,000. So we're going to use the same, so calculate the number of turns in the secondary. So we're going to say NP over NS is equal to VP over VS. We're told to find the number of turns in the secondary. So what is the number of turns in the primary? The number of turns in the primary is 1,000. It's 12,000 over the number of turns in the secondary is exactly what we're told to find. Then equal to the voltage in the primary. The voltage in the primary is 240 volts over the voltage in the secondary now is 12 volts. And right from there, there's a lot that you can do because I think 12 can go into 12, 12 into 24 can only go 2 times. Okay, so here we have 20 and then we can cross multiply. So NS times 20, we're going to have 20 NS is equal to N1 times 12,000, we're going to have 12,000. Then you divide by 20 here, and also divide by 20 this side. So the number of turns in the secondary will be that 0 divides that 0. 2 into 12, that is 600. So the number of turns in the secondary coil will be 600. Why? Because this is a step-down transformer. The number of turns in the if this is a step-down transformer, the number of turns in the primary must be more than the number of turns in the secondary. That's what we said. Look at the number of turns. 12,000. Okay, 12,000. And here in the secondary, 600. Yeah, which is a very big change. Okay, it's a very big change actually. So that is the first question that we have. We were told to find the number of turns in the secondary coil. Then the other one says, assuming that this transformer is 100%, has to be 100% efficient. Calculate the size of the current in the primary coil. Calculate the size of calculate the size of current in the primary coil. Size of current in the primary coil. Of course, that has to be done under the assumption that this transformer is 100% or 100% efficiency. So what we're going to do is we're going to use the general equation. We're going to use the general equation. Every information that we need is right that's here. So what the current in the secondary, I thought that is 2 amps. So we are saying that power in the primary is equal to power in the secondary. Now, what is power in the primary is voltage times current. So what is the voltage primary? The voltage primary is 240 times the current in the primary is what is of keen interest. Power in the primary is what we're going to find. But this must be equal to what is the power in the secondary? It is voltage times current. So what is the voltage here? The voltage is 12 volts times the current in the secondary, which is just 2. So here you can even divide by 240. You can also divide here by 240 volts. So that the current in the primary will be equal to the current in the primary will be so of course here you can see that 2 times 12 is going to give us 24, and then you divide by which is 240. So you find that when you divide 12 into 240, it's going to give you 0.5 amps. So the size of the current in the primary coil is 0.5. Okay, that's where we end for today.